continuation of activity 3. And in activity 3, we are constructing an inscribed square. You should have the patty paper that we used from the previous page. Have a highlighter, have a straight edge, and have something to write with. We're talking about the learning goal, constructing an inscribed square using a compass, patty paper, straight edge, etc. You can verify that you created a square inscribed in circle B. To do this, you need to show that all side lengths of the figure are equal and each interior angle is a right angle. Cool, okay. Maybe that's actually like 2 things that we need to do. Show that all side lengths of the figure are equal, highlight that, and each interior angle is a right angle. I can do that. So suppose BC is equal to X, and when they tell you information like this, a little box around it, you should go to the diagram, find that side length, and write X there. Now, because there's a spike on that line, BC, all of the other lines around the shape also have that same expression. So we can put an X there, we can put an X here, we can put an X there too. So that's 4 lines because there are 4 radii that are used to create the circle. This box right here means 90-degree angles. So actually what this is a right triangle. And if you remember your 8th grade geometry, a squared plus b squared equals c squared is the Pythagorean Theorem formula that we need to know. How long is AC? Me wonders. Well, it's this. This is A, this is B, these legs of the right triangle. And then the chord that goes across from A to C is the C part of the formula. And we don't know what that is. So I'm going to put a little question mark right there. But we're going to take 1, 2, 3. I have 3 highlight colors. I'm going to go green is A. I'm going to go yellow is B. And I'm going to go orange is C. I'm going to put this into the formula. Notice I'm not highlighting the square. I'm only highlighting the letter. So this is x squared plus, because x goes where the A is, and then x goes where B is, but we don't know what C is. So I'm going to put a question mark and square it. One of the review questions that we had for this lesson said, what is x squared plus x squared? Now I know why we had to ask that question. It is 2x squared, because there's 2 of them. But the question mark is still squared. And when the question mark is squared, that doesn't actually tell us what the single question mark without a square, how big that should be. To cancel a square, remember this for your future, use a square root. And if you do something to the right side of an equal sign, the equation becomes unbalanced. So you have to do the same thing, square root of all, to make the whole equation become balanced again. A square and a square root, cancel. A square and a square root, cancel. But there's still a square root on the 2 because the 2 is not squared right here. It's just hanging out. So we're going to put a root 2, a little tag that it goes over. I'm going to move this. It's the orange up to here. Root 2x, which means root 2x, which means root 2x, which means root 2x. The reason that it goes all the way around is because all of these lines are the same length. How do I know the same length? Well, if you look at side, angle, side of that triangle, this triangle has the same side, angle, side. So these 2 triangles are congruent. And then these 2 triangles are congruent because they have the same side, angle, side. And this last triangle, side, angle, side. So therefore by SAS, all 4 triangles are congruent. And that means that all of these hypotenuses, hypoteni, I don't know what the plural is, but they're all going to be the same length. Let's keep going. You can also verify that all sides of the figure have equal measures using the Pythagorean theorem. So actually, I'm going to take this information up here and put it down. So that's a squared plus b squared equals c squared, x squared plus x squared equals something we don't know about squared. You add them together because there's two of them. That makes 2x squared. It's still an unknown value squared. And then you square root both sides to cancel the square on the question mark, which makes just a question mark by itself. But over here, the 2 doesn't remove the square root, but certainly the x being squared and then square rooted removes the square root on the x. Pythagorean theorem. Now you know each side length of the figure. You can use the converse of the Pythagorean theorem. What is that? Look in the glossary, or better yet, look over here. The converse of the Pythagorean theorem says that if a squared plus b squared is c squared, then the triangle is a right triangle. So we've allowed us to make this conjecture that using this information, all three sides of the triangle create a squared plus b squared equals c squared, then that triangle must be a right triangle. Okay, let's go with that then. So the diameter of the circle is made from two x's, two x radii. This edge of the circle and this edge of the circle are the legs of the right triangle. So if I focus on this as A, Pythagorean theorem, mind you, and this length as B, and then across the bottom, that's going to be C, I'm creating this whole triangle shape, and it would be really nice if we could show for certain that that's a right angle, that's a 90 degree, because don't the angles in a square have to equal 90? This is what we're going to do. We're going to go a squared plus b squared equals c squared. Look back up at that circle. Go back in the video half a minute, or watch right here. A is root 2x. B is root 2x. And C is double x's, as in 2x. Not with a square root, though. So down here, A is going to be root 2x, and we're going to square it, plus B, well, I don't need to write a B, I'm going to write what B is. Look back up at the circle. Root 2x and square it. Look how I put a little tail on the end of the square root. X does not get square root covered. And then we're going to say it equals, well, let's just see what it equals. When you square something, you're doubling it, but not only doubling it, you're multiplying it by itself. And it turns out root 2 squared is 2. X squared is x squared. Root 2 squared is 2. And x squared is x squared. I hear it now. X squared is x squared. But look how the square roots go away because of the square canceling the square root. Now, what is 2x squared plus 2x squared? It's 4x squared. But if you take this and break it apart, you can break it apart like this. You can break it apart into 2x as a product and then square that product. And didn't I tell you up above that this side right here was double x? Here's where double x pops out. This is C, and these were B and A. So therefore, the Pythagorean theorem uses the expressions from the square up above. So triangle A, get my face out of the way. Triangle, move it, there we go. Triangle AEC is a right triangle. And angle A is the right angle. So if angle A is a right angle, then all you got to do is rotate the triangle around. that means that E is a right angle, D is a right angle, and C is a right angle. So that's 4 right angles with 4 congruent side lengths. We must have a square. Confirm. Hey, we're gonna just one more thing we need to make sure is it made for a point for this activity to wrap up. That's on page 238. That's the next video. Thanks for watching the last video, this video, getting better at mathematics a little bit at a time every day. Always feel free to ask questions, stop by after school, or drop an email, a like, a comment, a question, so that if you are concerned about something, we can talk about it. Thanks for watching this video. Click on the next one, jump to the next page. Let's keep learning mathematics, learn a little bit of mathematics more and more every day, every time. Thanks. Bye.